This exercise is to create a model for Canton Tower using Grasshopper. If you go to this website, then you'll see the photo and also some descriptions on Canton Tower. We start by adding a circle. So we can go to curve and then find the circle component. So this component will take two parameters. The first one is the plane, the base plane for creating the circle. And the second parameter is to specify the radius of the circle. So the component is initialized with default value. The default value, the plane is on the origin of the XY plane. So here we can see this grid. This grid represents the coordinate system, the plane. And the default value for radius is 1. So here we see a green circle with radius 1. If we look at this circle from the perspective view, and you can see that the radius is exactly 1. So we can modify the radius by changing the radius. So if we click on an empty space and then type in the preferred radius, for example, like 10. Okay, let's maximize this perspective window and zoom out so we see there's a circle. For creating the Canton Tower, we also need to specify the height and the circle on the top. So we can use a transformation to move this circle to the top. Or we may create another circle, because then we can specify another radius for the top circle if we want to change the size of it. So we create another component. But this time we need to specify a point or a plane which is above the base plane. So we can specify the top of it. And we can do that by moving the base plane to the top. Okay, so for example, we can extract the default plane, click the right mouse button, and click extract parameter. So this is the plane. Simply use the default value, and then we can make a transformation. If you go to the transform category, then you can find this move component. So we will move this component to the position by specifying the motion vector. So if we want to move it upward, then we can find a vector for the z-axis. So we go to this vector category and select the z vector. And then we connect it here. And then we use this new plane. Now you see this plane here on top of the base plane. Okay, because the default value for the z vector is 1. If we want to increase the height, maybe we make it like 100. Then we zoom out, then you see the plane is above the ground with 100 unit. Then we use this plane to create the circle for the top. Now we have a circle of unit size. And now we can use another slider. So we copy this, Control C, Control V to specify the radius. Then we have another circle. And we can slide the slider to change the size of it. So for example, we can make make it smaller. Okay, now we have the two circles. Now we want to divide this circle into a number of divisions. Then we can connect these divisions so to make the rules that support the top circle. So we go to curve category, and here is a component to divide the curve, and then we connect the base curve to it. You can see that it is divided into 10 segments because the default value for this n parameter is 10. We can also change it. Maybe we want to make it more, so we say 15. Then we connect to it. Then we can specify the number of divisions. Okay, and we also like to divide the top circle with the same number of divisions. So we can copy this divide curve and then connect the top circle to it. So we have both circle divided with the same number of divisions. Okay, and we can take a look at the output. Okay, so for example, we can use a text panel. Here you go to parameter category, and here this yellow square is the panel component. With this panel component, we can show what is inside of this output parameter. So from here, you can see that this divide curve component has its first output as a list of points. And this point dissect the curve into a number of segments. So we can connect this point with the points on the top curve to make these rulings, this linear element that connect the top and the bottom curve. So we go to curve. Here we can use this line component to create lines to connect this. So now we create a kind of truncated cone. Okay, but this is not Canton Tower. We take a look at the picture. So what we need to do is to rotate one of the curve so that all the line, connecting line, will lean to one side, and total these ruling lines make a hyperbolic surface for the beautiful shape. So we can do that by rotate the top curve for a degree that is specified by us. So we can go to transformation again. So now we choose, like here, this component, which means we can rotate a geometry based on a plane. Okay, here it requires a plane, and we can have this base plane for the top geometry, and then we can specify the angle. So perhaps we would like to make a rotation between, say, 0 to 180 degrees. Okay, so to create a slider for that, we can specify the minimum and the maximum value and the desirable default setup value. So we start from 0, and then we type in the smaller sign, and maybe we need 45, and then smaller than 180. Okay, click enter. So here, this slider, we can slide between 0 and 180. And here, the input, okay, the default angle is measured by radians. But if we want to make it by degree, then we can click the right mouse button and choose this degree item here, and then we connect it. Now the circle is rotated, but we cannot see it because it is a circle. But if we use this rotated circle for the division, then you can see that the lines, the ruling lines that connect the top and the bottom are leaned. Okay, so if we increase the rotation, then you can see that the shape become more and more like the Canton Tower. And perhaps if we also want to rotate it in the opposite direction, maybe we can increase the range for the angle. So we double click it, and then we can change the minimum value, double click it, say minus 180. So we increase the domain for the parameter. Okay, so now we can rotate the other side, the other direction, to make it the other way. Okay, so this is the first exercise. Let's stop here.